Hey guys, Mr. Brown with the last part of the 6.9 lesson, using your calculator to come up with a regression model with polynomials. Now, if you remember Algebra 2, we did linear regression models, we did quadratic regression models, now we're going to do higher order polynomial models. So here are the steps for using the calculator. Take a second, take these down in your notes, pause the video if you need to. Before we get into the first example, what I want to point out is a couple of things here. We have this r squared, and depending on whose class you had for Algebra 2 last year, you may not have learned what this is. What this is it's a value that tells you basically how good a model is, how closely it actually models the data, how that equation models the data. So if it's 1, you can think of it like it's 100% accurate and maps it perfectly. Now, the ones we're going to be doing aren't going to be perfect, but they're going to be pretty close. If this is like the r squared value is like a 0.99, you can kind of think of it as it's like 99% accurate, which is really a pretty good model. If it's something like a 0.75, 75% accurate, that's not quite as good. So the closer it is to 1, the better. All right, so a couple of things. In order to get this r squared value, you are going to need to do something called turning diagnostics on. So turn on your calculator. To turn the diagnostics on, hit the second button and then 0 where it says catalog in blue. So 0, it gets to this list. Now you can start scrolling down and go down to diagnostic on. However, if you notice, little A up there, that means I can type in a letter. Now on my calculator, the letters are a little green ones that are in the top right corner of each button. So this is where D is for diagnostic, and it's automatically scroll down to the beginning, the first thing that started with a D. So now I've got a shorter distance to scroll. All right, so diagnostics, we want to turn diagnostics on. So hit enter. And now a lot of students make the mistake of thinking their diagnostics are on at this point. All this has done is brought the command to the menu where you can execute the command. So in order to do this, in order to turn it on, you actually have to hit enter a second time. So it says done. Now the diagnostics are on. All right, so let's take a look at the first example. So the first thing we're going to do, we've got polynomial best fit for this. We've got speed, then gas mileage, I'm assuming, or maybe it's gas consumption or something like that. What would you predict the gas consumption would be at a speed of 70? All right, so we're going to go stat. The edit menu is the very first one, so hit the stat button right there and then just hit enter. Now, your lists might be full of stuff, right, that you need to clear out of there. To efficiently clear it out, scroll up to highlight the list you want to clear. I'm going to clear out list 3 because I don't need to use it. Hit the clear button and then hit enter. And it will clear out that list so then you can start entering your values. If you accidentally delete them, so if I accidentally hit delete instead of clear here, it's going to completely remove that list. Now that's not a big deal, it's actually a pretty easy fix. If you notice above delete, it's INS for insert. So if I go second delete, I can now insert a list back in. Now if I look down at my 1, 2, and 3, there's a little blue L1 up above the 1. That's list 1. So if I go second, the blue button for the blue function, and then the number 1, it will plug in and then enter. It will plug in my list 1 and whatever values happen to be there when you deleted the list, or whoever deleted the list. Okay, so what you're going to do, enter the top set of data into L1. These are like your X values. So those are your X's. That's your L1. The second one are your Y values, L2. Okay? So mine are already in there. After you have them entered in L1 and L2, double check that you have the same number here, right? If I have a different number of values in list 1, for instance, like if I throw an 8 in there, now if I go on to the next step, it's not going to work. It's going to give me a dimension mismatch error. So if that happens, that's one thing to check. And you can kind of check before you do it just to be sure. All right, so deleting a single value, I can use the delete button. Okay, so now my lists are in there. I know they're good. I'm going to hit Stat. Now I'm going to scroll one to the right to the Calc menu. And we're going to start with the quartic regression, the highest degree regression model that the calculator can do. We're going to hit Enter. Your screen might look a little different, but either hit Enter or you can scroll down to Calculate and hit Enter again, and it will give you a screen that looks like this. Now, one of the steps was to look at this A coefficient, right? So the top one here. Notice that there's a value there. It's not 0, but this e negative 7. That's scientific notation, and e to the negative 7 means that it's a very, very tiny, insignificant decimal number. It's negative 0.000003, and then the rest of the number after that. So this is basically 0 if you see this e negative whatever. Okay, so because this is basically 0, I'm going to move on to the next regression model. So Stat Calc. Instead of quartic, I'm going to do one less, which is cubic. Hit Enter, Enter a bunch of times. And now my A coefficient, it's still a very small number, right? 0.001, but this is a much more significant number. For our class, if you don't get that e to a negative value or it doesn't legitimately just equal exactly 0, you're going to use that model, okay? Okay, so our polynomial of best fit, right? If you remember in Algebra 2, you've got ax cubed, bx squared, cx plus d, and then you've got an a, b, and c and d value. You're going to plug those in for a, b, c, and d. You're going to leave the x's alone for now, but you're going to plug in for a, b, c, and d. So our polynomial model would look like this. Y equals our a value 0.001 x cubed. Now, I rounded to 3 decimal places there, so I could argue that I'd want to continue rounding to 3 decimal places. I think the ones in the test, if you do 2, you'll probably be okay. All right, minus 0.113x squared plus 4.134x, and the d coefficient, our constant, minus 24.867. So that's my equation, that's my polynomial model that matches this data as close as I can. All right, so what would we predict the gas consumption would be at a speed of 70? We're going to have to plug in a value. One thing that you do need to make sure is that you're plugging it into the right spot, right? Speed, that was my x value, right? So I know that 70 is going to get plugged in for x. So that means it's going to be 0.001 times 70 cubed minus 0.113 70 squared plus 4.134 times 70 minus 24.867. And if you show this work on the test and you then plug it in wrong in your calculator, you're probably going to get at least partial credit for that because you're showing that you're trying to do the right thing. All right, and then also, before I plug it in, that r squared value, 0.99999, this is a really close model. All right, so let me just plug that in real quick, or as quick as I can. Hopefully I don't screw this up because it does take a little while to plug it in. All right, and I got 53.813 for my fuel consumption. Now, if I kind of think, does that make sense or not? I think it does. I think it does. I mean, it's generally going up, and then so as it goes up to 70, it might start to, the graph might start to really ramp up as the speed gets higher and higher. All right, so just for a quick visual of what we just did, if we represented this as a scatter plot, another way that I know that this is I think I did it right. Here's the actual scatter plot of that data, right? I think the scale down here is counting by 5, same thing vertically. You know, in Algebra 2, we looked at something like this, and we would have put a line through it with a line of best fit, like that. But if we kind of connect the dots, you can see that it's not really a line. It's kind of a little S shape. And so the model, the actual graph of the equation, here's how it fits that data. So it's pretty close, but you can see it's not perfect. And it's a cubic, right? It actually has 2 turning points, one here, right? So it changes direction here. There's a curve here, and then there's a second curve down here. They're very shallow, but they're there. There's a relative max right about here, and a relative min somewhere down here. All right, let's try one on our own. So if you want to pause the video and try this one on your own, and then unpause when you're ready. One thing that I would say with years, right, 1,950 is not necessarily the best value to use here. If I were to do this, the way I'm going to do it, and the way your teacher also wants you to do it, is whatever this first year is, make that year 0, okay? And then 1960, that's 10 years later, so that one's a 10. And then 1970 is 20 years later, 30, 40, and 50 years later. That's going to give you nicer numbers to work with than if you actually use 1,950. All right, again, this is your L1. These are our X values. This is our L2. Those are your Y values. And if you plug that in, we're going to go stat. So I hit the stat button, edit, and these are our values. Again, I have the same number of items on each side, right? There's not an extra one here, so that's good. Stat, scroll over to calc, down to quartic regression first. And look, we've got that E-5 again, so that we're going to go on to a cubic and see if that one fits a little bit better. So stat, calc, we'll go down to cubic, calculate, and these are the coefficients for the model we're going to use. So the actual model, y equals 0.12. We'll go to 2 decimal places on this one because they're bigger numbers. So 0.12x cubed minus 4.21x squared plus 146.37x plus 2851.64. Now, one question sometimes we get, how do you know if it's a minus or a plus, right? If it's a negative value, that coefficient is going to be a minus, and then if it's a positive value, it's going to be a plus. R value, again, 0.99999, really a good model. Okay, what do we predict the population will be in 2019? So don't use this model where you change the values to 0, 10, 20, and 30 based on the years after 1950 and then plug 2019 in, right? How many years after 1950 is this? It is 69 years after. So this is going to be 0.12 times 69 cubed. All right, like that. And if I plug that in, I wish I would have done that ahead of time. I preloaded all the tables, but I didn't think ahead enough. So it'll add a little extra time on here. I'm sure you can figure out how to scroll ahead in this video. All right, so our projected population is that. Since we're talking about people if you use the decimal value, I don't think any of your teachers would count that incorrect, but we can certainly round or truncate in this case, so just chop off the decimal like that.